Welcome to today's Explainer. So today, we're talking about destroying an invisible wall. Imagine the brilliant engineers building your favorite apps, right? Well, more often than not, there's this incredibly frustrating barrier between them writing really great code and that shiny new feature actually making it to your phone. If you've ever found yourself wondering why major tech companies sometimes seem to just move in slow motion, the concepts we are breaking down today are the exact solution to that mystery. We are diving into platform engineering, basically the invisible foundation of the entire modern tech world.
Okay, I want you to picture this. It's honestly a classic software developer's nightmare. A developer has a truly incredible idea for a new feature. They write the code, they test it thoroughly, and it works perfectly on their laptop. And then they wait. They wait 3 entire days for the IT department to set up a server. Then maybe another 2 days just to configure a database. And heaven forbid the deployment crashes the system at 2 a.m. They are completely on their own, frantically trying to fix it while half asleep. You gotta ask, why on earth does it have to be this hard just to launch a simple update?
And this brilliantly illustrates exactly the problem we're solving today. On one side, you have life without platform engineering. It's a world full of manual bottlenecks, waiting around for other humans, and digging through endless raw server logs hoping to find a needle in a haystack. But life with platform engineering? It's entirely different. It's smooth. It is fully self-service. A developer can spin up a database, configure their monitoring, and deploy straight to production, all in a single afternoon, without waiting on a single person.
To really grasp the value of this role, we have to name the enemy. And that enemy is called developer toil. Toil is that repetitive, manual, totally soul-crushing work that just bogs engineers down and has absolutely nothing to do with building the actual product your customers use. The entire goal of a platform engineer is to completely eliminate this toil. They literally exist to make developers so incredibly productive that the only thing slowing them down is their own creativity.
So let's look at Section 1, Building the Tech City, and how platform engineers create the foundation. To really understand what a platform engineer does, we've got to step back from the raw code for a second. Think about this. Just one single platform engineer can give 50 developers actual superpowers.
Let's imagine a bustling city for a second. Your software developers? They're the people building the houses, the beautiful shops, the restaurants that the citizens are actually walking into and interacting with. But absolutely none of that works without the roads, the electricity grids, the water pipes, and the sewage systems running right underneath it all. If developers build the city above ground, platform engineers are the ones building the invisible infrastructure beneath it all that makes the whole city actually function safely.
Now, in technical terms, this city infrastructure is called an internal developer platform, or IDP. You can think of the IDP as the ultimate self-service vending machine for developers. Instead of filing a bunch of IT tickets and waiting days for a human to set up a new server, developers just use the tools inside the IDP to get exactly what they need instantly. Platform engineers don't build the product the customers use. They build a platform that lets the team build the product faster.
Okay, let's dive into this next part. Section 2, the Platform Toolkit, translating the jargon. Because if you look at platform engineering job postings, it can look like a totally intimidating alphabet soup of acronyms. But we're going to demystify that right now using our city analogy. Let's walk through this row by row, mapping these complex tech tools directly to everyday city concepts. First up, we've got Terraform, which acts exactly like the city's blueprints. Next is Kubernetes, which is your master traffic controller. Then we have CI/CD pipelines, serving as the automated highway. And finally, observability tools, which act as the CCTV and fire alarms. Let's break these down real quick.
So, starting with Terraform. Platform engineers manage massive cloud platforms like AWS or Google Cloud, right? But they don't do it by just clicking around in a web dashboard. Actually, scratch that. They don't manually do it at all. Instead, they use Terraform to write infrastructure as code. They just write text files that describe exactly what servers and networks should exist. It is quite literally writing a blueprint for your city and letting a robot build it, instead of stacking every single brick by hand.
Next up is Kubernetes. Modern apps run in these little packages called containers. Just think of them as standardized shipping containers holding pieces of software. Well, Kubernetes is the ultimate traffic controller. It decides which server runs which shipping container. If a container crashes, Kubernetes automatically restarts it. If a massive spike in web traffic hits your app, Kubernetes instantly scales it up by adding more containers so the developers never even have to lift a finger.
Then we have CI/CD, which stands for continuous integration and continuous deployment. Picture an automated highway that takes developers' code straight from their laptop all the way into the live app.
A developer pushes their code onto this highway, and the system just takes over. It auto-tests the code, checks for security vulnerabilities, and deploys it live. The code moves from an idea to the customer without a human ever clicking a single button. It's basically magic.
Now, what's really interesting about this slide is how a platform engineer prevents those catastrophic 2 a.m. disasters we talked about. It's through something called observability. If something breaks, you need to know about it instantly. So, platform engineers use tools like Prometheus, Grafana, and Loki to set up beautiful visual dashboards and alerts. It is exactly like installing a network of virtual CCTV cameras and highly sensitive fire alarms across your entire digital city. You can discover and fix issues while your customers are completely oblivious that anything even went wrong.
Moving into Section 3, Essential Skills to Start and Your Path to Platform Engineering. Now, if you are listening to this and thinking, hey, I want to build the city, understand that this is a journey. Nobody just wakes up as a senior platform engineer. People gradually build these skills, usually transitioning from software development, sysadmin, or DevOps backgrounds.
So let me guide you step by step up this ladder. Step 1, get your cloud basics down on platforms like AWS. Step 2, embrace Linux to navigate the command line. Step 3 is infrastructure as code, so learning Terraform. Step 4 brings in containers, starting with Docker and then leveling up to Kubernetes. Step 5 is scripting with Python or Bash to automate tasks. But I really want you to look at Step 6, communication and empathy. This is the absolute most underrated skill of all. Because if you don't actually understand what developers are struggling with, you can't build the right tools to solve their problems.
And let me tell you, that empathy pays off. Section 4, a highly lucrative career and the developer productivity wall. The reason they desperately need these engineers is that every single scaling company eventually hits a wall. Onboarding starts taking weeks, deployments get super scary. When a company hits that developer productivity wall, they realize they absolutely must have a platform engineering team.
Look at this number, $250,000. Because the demand for these problem solvers is growing so much faster than the supply, the compensation is explosive. Senior platform engineers at top companies are pulling in between $150,000 and $250,000 a year. It's highly lucrative because it sits right at the critical intersection of software engineering, infrastructure, and security. If you love complex systems, this is as intellectually stimulating as it gets.
So, let's wrap up our explainer today with this powerful thought. Platform engineering isn't always glamorous, you know? There's no shiny new button your customers can click on, and nobody outside the tech team really sees your work. But when a developer ships a brilliant new feature in an afternoon instead of 3 weeks, that's your work. When production stays online during a massive traffic spike at 2 a.m., that is your work. You are the absolute bedrock. So I'll leave you with this. If you were building the tech city of tomorrow, would you just start haphazardly stacking houses? Or would you focus on laying down the invisible, unbreakable foundation first? Think about it. See you next time.